Hi, my name is Mr. Barnes and I teach math. This lesson is going to be about compound interest. And it's an important one because no matter who you are or where you come from, compound interest is going to have an influence in your life. Either you're going to want to borrow money that you don't have yet to buy something that you want, or you're going to want to make money using compound interest. And they both work the same way. We're going to look at three different formulas and try to determine the details of each. So let's get started. This is the first one. This is when you have money that is compounded annually. Now, the idea of compound interest is you have this principal here. You multiply it times a rate. And that rate, well, if you're borrowing money, that's money you'll have to pay back to the bank for the privilege of borrowing the money. And if you are making money, well, that money goes to you. So there's initial money, which is your principal. That's what they call it, the principal amount. And you're multiplying it times a rate, a certain number of times to get that money. Now, you start with less money than you end up with is the idea of it. But if you're going to borrow $200 from the credit card, you would have to pay them back more than $200 depending on what the rate is. So we have four different variables here. The output, which is the money that comes out, the initial money, this rate, and the input here is going to be time, because you're going to put in time and get out money. That's the whole idea of compound interest, is you're changing time into money. Either you're borrowing money over time, or you're putting money into some sort of account, and like a savings account does this too, for a certain number of time, and you're watching the dollars and cents roll in. So we have these four things here. The trickiest part, like if I was borrowing $2,000 at 4.3%, compounded every year, just once a year for 5 years, the principal would be 2,000, and the rate, you'd change that percentage to a decimal by moving the decimal over twice. That's what a percent is. It's out of 100, cent meaning 100. So you divide this by 100, move the decimal over twice. And when you put that into the formula, make sure that you use PEMDAS, do parentheses first, then the exponents, and then multiply those two numbers. Now I want you to try that in your calculator to make sure you get the same answer. Do you get $2,468.60? If you were my financial analyst and you were to tell me that this would become $2,468.59, being 1 penny off, I would probably find a new financial analyst, because details really matter in this. Every cent counts. So make sure that you're being very careful, both with the significant figures of that rate and also in the rounding. So get that answer. If you want to pause the video and see if you can get that right answer using your calculator, you and your calculator should have a pretty positive relationship. Make sure that you get that. And if you get it, awesome. But the good news is, cool. And the bad news is, well, it's actually, life is not that easy, because very often you'll have things that are compounded periodically. And you'll see that this is very similar to the same formula, but what was a rate is now going to be compounded a certain number of times a year. If it's compounded annually, you're just doing it once a year, probably December 31st, at midnight. You compound your money, and then the output is more. So that just happens once a year. But very often, you'll compound things in a certain number of times per year. And that's what this N, here I'll circle it because the R and the N kind of look alike. This N that shows up there and there, you have to divide the rate by that number of times per year the money is compounded. But you also have to put it into the exponent, because every time that you compound the money, this is going to be changed. So when you do that, there's different kinds. There's daily. Daily is 365 times a year. I guess for a non-leap year, we just kind of assume it's a non-leap year. There is monthly, which we're using for this example, which would be 12. And there is also quarterly, which means the number of times per year. Oops, it's quarterly, which, and in that case, would be 4. So same kind of idea. If it's $2,000 at 4.3% compounded monthly for 5 years, you're going to be putting in that 12 there and there. Now, totally job for your calculator. And the numbers are kind of small, so let me just lift them up here. put those numbers in, and get the right answer. Now, it's almost the same answer, but you've made an extra 17 cents by my count. No, $10.17. Look at that. What was this now is $2,478.77. Over $10 is now in your bank account because it's compounded more. Now, the rate hasn't changed per year. It's still an annual percentage rate, but because we're doing it 12 times per year, it's more of a chance to get interest into the output here. When you get more interest into the output, the next time it's compounded, there's more money to gain interest. You're getting interest on interest on interest eventually. And, if you do it 19 times, that's done to the 19th power. So every time you can compound, it's a good thing. And it made us 10 extra bucks here, which is nice. But what if? You see how we did it 4 times a year, 12 times a year, 365 times a year? What if we did it every split second of every day? What if we never stopped? What if we did it infinite times a year? Kind of a crazy idea, right? I mean, is that even possible? It is possible using this idea of E. Now look at this crazy formula right there. In some ways, it's actually easier, and in some ways, it's a lot weirder. This E has that built into it, compounding things infinitely built into it. In fact, if you're going to make this N here infinity, as it approaches infinity, you would eventually get it balancing out to this. I guess it would be kind of like an asymptote. This is an irrational number like pi, and don't worry about it so much. It's about 2.7. It's not actually a variable. It's a constant, even though it's an E. And what you have to do for this one, if you wanted to find out, sorry about the focus, $2,000 at 4.3% compounded continuously. Now that's infinite times per year. As long as you're compounding, it's going to be infinite times, which is an awesome idea. And if there's a way to make money, people will probably think of it. And this is a way to make a little more money. See, not a lot more. I mean, it's just like $1, a little less than $1, 95 cents more than that. And with this infinite times, but it still works. You take the principal times e to the power of the rate times the time. You don't have to put the n in because the n would be infinity. And if you want to know how to do that, you probably need a calculator. Well, I assume, I don't know how you'd be able to do this without a calculator. And very often there's an e to the power of key. Here, let me see if I can show you on mine. There it is. It's right there above the natural log. It's that e to the power of x. So I would take e to the power of, what's the rate? 0.043. You don't need the 1 in there. Times the number of years, which is 5. And I'm going to take that and multiply it times the principal using PEMDAS correctly. There it is. And I rounded to the nearest penny, so 72 cents. Remember, 5s round up and 4s round down. So those are the 3 different formulas for you there. Please write those down in your notes and practice them. You don't want the first time you're going to be looking at this stuff to be the bell ringer or the test, because it does take practice. The 2 that get used the most often are these 2, though, with the periodically and the continuously. I really haven't seen very many compounded annually in my life, but I have seen both of these things for loans, for credit cards, and for like savings accounts. It's a way to make, a couple pennies a lot of times, depending on how much you have in there. Now, I am not saying that money is the most important thing, but I am saying it is a big part of our lives. And you want to hold on to money and make money so you can spend it on goods and services that you like. If you need anything at all, give me an email. That's the idea of compound interest, but really it takes practice. Once you've made all the mistakes and figure those out, there's only so many mistakes you can make. So make those mistakes early and often. I'm already proud of you. And give me an email if you get stuck.